Well, normally I recommend that you go through the Resource Explorer and find examples of things to do like blinking LEDs and timers. I do want to show you kind of an in-depth how to approach this if you didn't have those examples. Just because I think it's a good exercise to show what information is in a datasheet and also how to kind of interpret that information and use the knowledge that you should hopefully have from things like CompArc and maybe some other past experiences to get this thing to do what you want. So just as an example here, I want to blink LED 1, I think it's LED 1 or LED 0 on the G2553. It's the LED that's actually hooked up to pin 1.0. So to start out, I'm actually going to, before I even go into the new project here, I'm going to quickly, not go to Scopy, I'm going to quickly go to the datasheet. So the datasheet here is, again, one of the most important things to have open whenever you're actually working with any of the microcontrollers. This literally needs to be on a tab, a second screen, just ready to go. So if I take a look at it, and if I go down, we're using the 20-pin device, I'll quickly take a look and see P1.0 is hooked up to pin 2. That's great. It also has all these other functionalities. Cool. So what I go do from there is I say, well, I want to use pin 1.0 as what's called a general purpose input output. So this P1.0, I want it to have that functionality, meaning I want to connect my general purpose IO peripheral to that pin. I want it to control that pin. So I go, okay, well, what do I need to know from there? You could maybe start scrolling, but if I look, P1.0, that's an output port, right? So if I go here and I click output ports, you might be able to find it. And the answer is no. So this is a good lesson, is you got to take a look around and see if you can find certain things. So I'm looking for things like the port schematics. That's more important. So I'm looking at pin 1, port 1, pin 0. Here's the schematic, and I think in a previous video that's either before this or maybe it's a video that's going to be after this, I dive in a little bit into how to use this information. So just as a recap, this is the circuit that's hooked up to pin 2, right? So port 1, pin 0, this is what's hooked up to it, and there's a lot of stuff here. All these muxes, tri-state buffers, inverters, AND gates, all sorts of stuff here. And it's all here to provide a multiple function pin. This thing isn't just a pin that you can control on and off from code. This also hooks up to the timer modules to let it control from that, to analog modules to take in inputs. It also could be an input itself, a digital input. It hooks up to some of the peripherals, like the serial peripherals or comparators, you know, all of these different things. And this diagram is here to show you how that happens. So for our example, we just want to simply control this pin state using the GPIO peripheral. So to use the GPIO peripheral, we need to look at the following registers. We need to look at the direction registers, the select registers, a whole bunch of stuff. So how do I figure out how to control this? You could work your way backwards if you wanted, or go to that other video to find that. Or if I just happen to scroll down just a hot second and I look at it, this datasheet already did it for you. So if I want my pin 1.0 to be treated as an IO, an input or an input output, here's what I need to do. I need to set this register, p1dir.x. How do I read that? It even gives you an X column. It says for pin 1.0, X is 0. So p1dir bit 0 needs to be set to either a 0 or 1 based on an input or an output. And you need to set these registers, the P1 select register and the P1 select 2 register, their specific bits to 0. And then it points us to the general purpose input output peripheral and how that works. So I'll have to open up another data sheet for that. But for now, we have everything that we need to know. You could either go through this diagram or this chart. I want to turn it into an IO line so I can toggle it. So I'm going to go here over to Code Composer, and I'm going to create a new project. Now again, I'm going against every piece of advice I normally give for this class, which is just click blink the LED or find an LED example. But for here, like I said, I want to show you kind of going from default. So if I type in my target is the MSP430 G2553. Perfect. So that's my target. What connection I want to use, I will give it the project name blinking LED from scratch. And I want an empty project. And I hit OK. That's what I want. All it's going to give to me is a project. Here's our project with a few folders and this main.c file. Look what it gave us. That's it. It gave us the include statement for the header file, for the MSP430 header file, and a main loop that turns off the watchdog timer and returns a 0. Cool, right? Like that's nifty. So if I wanted to change my, I wanted to actually blink this LED, well, let me kind of flip back and forth here between my datasheet. So again, we're looking at this column here, right? Like I want it to be an IO line. So if I take a look at it, well, I need to set this register, my direction register, to an output. A 0 is an input, a 1 is an output. The font here makes it look very close. So what I need to do here is then say, okay, I'm using pin 1.0, so P1 dir is equal to, so this is an 8-bit register, and I'm trying to set bit 0, given by this. I'm trying to set bit 0 equal to a 1. I can do that a couple ways. I could destructively do that, meaning that I don't care what's in P1 direction. I'm just going to overwrite it with my macro for, 0000001. If you all don't know what these macros are, you can literally hover over them and it tells you. So it's in hex, it's 0001. And then this even tells you, if I hover over it, it says, hey, look, this is a special function register and it controls port 1 direction. The problem here is, so this is, I'll write it in the comment here. Let me fix that real quick. This is a destructive assignment. So this is no matter what, if P1 dir was equal to, let's say 011000001 or 00. After this assignment, P1 dir is going to be equal to 000000001. That's why I like to call it destructive, is because it just blows out any other information that was in this register, or in this, in the register, and replaces it with something else. That's not really what I'm looking for. That's not typically a good practice. Maybe for like some initialization you can set it to 0, or if you want this thing to boot up and have a specific, like, I need all my pins to be an output because the circuitry attached to it needs to have a high Z, or maybe as an input for like high Z stuff. You could do this, but here's the kind of, in my opinion, the better way to do it. So I'm going to get rid of my destructive assignment. And instead, actually, real fast, I'm sorry if this is going to take a bit. I want to see if I can change my settings. Normally that would be like preferences. Can I change my font? Sorry, I didn't want to go through this. I'm realizing it's a little small to see. I will do that in another video. I'll change the font size here. So here's how I would actually do the assignment for P1.0 and setting it equal to a 1. I would use a non-destructive assignment. So I would say it should be P1 dir. And if I want it to be equal to 1, so I have to think back. If I'm working in the world of binary, and if this was P1 dir, so here, let me put my little comment out here. So a non-destructive assignment would be something like this. I have P1 dir is equal to my 011000000. After my non-destructive assignment, all I want to do is change 1 bit. So I want it to end up as 011000001. So to do that, hopefully you all know that from IES and some other stuff, is from digital systems, is P1 dir should be or equaled with bit 0. Since bit 0 is basically 7 zeros and a 1, what this does is it says if I OR something with a 0, it will always be itself, right? If I add 0 to something, think of it that way. If I add 0 to something, it'll always be itself. If I OR something with a 1, no matter what it is, it'll automatically become a 1. So this is just a little bit more of an efficient way to do things. And it's also non-destructive, meaning that if you just spent code, lines of code above configuring other pins, if you run this, it's not going to ruin everything you just did. So perfect. So I'm going to set, really what this is setting my pin direction. Okay. So I've got P1 dir is equal to bit 0. What else do I need to do? P1 select needs to be equal to 0, and P1 select 2 needs to be 0. Just a reminder, these are choosing from these muxes, so we're trying to pick the 0th position of the mux to let the GPIO peripheral take control of this. So to do that, I need P1 select, and I'm trying to just change bit 0 again. I need it to be equal to, I'm checking again, should be a 0. Non-destructive assignments for zeros are typically in the form of and equals. So take the current contents of P1 select and it with the inverse of bit 0. So this is basically creating a mask. So to talk about what this does, the commenting not lining up is going to bother me. So to talk about what this does, if I invert bit 0, that's going to give me 1111 1110. So what's cool about that is that means if I and something with a 1, it is always going to be itself. If I and something with a 0, it will always be 0 no matter what the previous state was. So with that in mind, we can actually non-destructively assign a 0 to this register. So that's what this does. This is non-destructive. So non-destructive assignment for P1 select. And I need to do the same thing to the other register. Now, I'll leave this for like another video for you to explore, but it's up to you if you want to. A lot of microcontrollers, when you reset them, certain registers get set back to 0. And you need to use the big 700 to 2,000 page datasheet, family datasheet, to see that. It tells you what registers are set to when they're reset. I believe the P1 select registers all go back to 0. But if you really just want to make sure that it always is set the right thing, we have enough clock speed and memory and just all this other stuff. Unless you're really caring about that one line of code, I would go ahead and spend the extra line of code to make sure that your ports are actually in the right, your port selections or those muxes are picked correctly. So now what? What if I want to blink my LED, right? So did I do everything I needed to? I set P1 dir, P1 select, all of these other things. I could technically set them as well. But I am going to, if you look at it for all of these things, they're all 0. So I'm just going to ignore that for right now. So I want to just control my LED and make it blink. So here's how I can do that. Let me do a while one loop. So while one, you can at me later if you don't like the fact that I'm doing if you don't like the fact that my brackets are down here. So if I want to blink the LED, if you take a look real quick, what we've done is we've basically said this mux, the mux is going to output whatever it sees here. And if we look at it, well, there's a tri-state buffer, and then our pin. So as long as these tri-state buffers are enabled, if I put a 1 here, a 1 will propagate forward and end up going to it'll actually set the output to a 1. If I put a 0 here, it'll propagate forward. Using the P1 select and P1 select 2, we basically, and setting P1 dir to be 1, look what happened. We said pick this channel, we've set this to 1. Now it comes down here, and if I have 1, awesome, it enables this. And as long as these two are 0, which we can go back and actually check all that if you really want. But basically, by setting all this, we've enabled basically the GPIO peripheral to control the state of this pin. Now we need to blink it. So this is what's going to control the state of our port, of our pin. So I'm going to go here, and it was P1 out, which is another 8-bit register. If I set it equal to a 1, my output's going to be a 1. If I set it equal to a 0, it's going to attempt to drive the output to a 0. So if I wanted to control pin 1.0, I should say P1 out. If I want to do a toggle, for example, if it was a 0, make it a 1. If it was a 1, make it a 0. I can use XOR. So if I XOR something, exclusive OR something with a 0, nothing changes. If I exclusive OR something with a 1, it inverts. So now I can toggle the LED. So toggle P1.0. And I believe my compiler command should be delay. And let me make it a, I don't know, 10,000 clock cycles. Now, this is a compiler command. You can use it if you want. This is extremely wasteful. There are many, many, many better ways to blink an LED, but this is just the way that we can do this for now. So with this, let's see if we did everything. So just as a recap, we set the direction of the pin to be an output, and we said that we want the pin itself, the state of it, to be controlled by the general purpose peripheral, which means that whatever we set here is going to be equal to others. So with that in mind, I should have turned off my notifications. I thought Do Not Disturb was on. That basically we should be good to go. So if I try to debug this and hit OK, I got errors. Great. Cancel. What's my error? Did I forget like a... Oh, does it not know what delay is? Yeah, delay is declared implicitly. There's other ways to do a delay, but you know what? I'm just going to blink it as fast as possible. Just for your sanity's sake. So let me re-debug it. Proceed. Let it run. Great, now we're in the debug session. So here's what I want to do is just to show you that the XOR thing is working. I'm actually going to step through the code. So we're in a reset right now. So we just officially reset everything. If I bring my registers over here, so it's a little bit easier to see, here's what I want to check. I want to show you what's happening here. So if I look at P1 dir, P1 select, and P1 select 2, right now they're all set to 0. So each one of these lines of code, changes are, I think, reflected in yellow when you're using a dark mode. If I hit next, look what happens. I've now just set my direction register to be an output. And actually TI does or Code Composer does a pretty decent job sometimes of saying like what these are, like as outputs or inputs. Sometimes they do, sometimes they don't. But in this case, we've actually changed the direction register. If I run the next line of code, it'll change P1 select. And if I change P2 select, great. You may notice that nothing changed, and that's because, well, they were already zeros. But I do want you to notice something. Actually, I'm going to rewind. So there's a restart here, and you'll see like boot.c, probably see it pop up. All right. I want you to take a close look at P2 select and P2 select 2, or P1 select. Wow, I'm blind. They're both 0. So if I run through this, nothing about that's going to change. Now we're here waiting for the LED to toggle. So if I look at P1 out, look at what it's set to right now. It's 1, 1, 0, 1. You know, we got all this stuff. If I want to non-destructively toggle it, hopefully if I hit next, it should set it equal to a 1. Perfect. Goes back up, checks the while loop, and if I let it run again, it'll basically change everything that we want. Awesome. So now if I take away my breakpoint and I just run the code, the LED should be blinking. Now, just to reinforce that you should be really doing this in front of an oscilloscope, this thing is blinking as fast as I can possibly drive it. So I'm going to make sure that I have channel 1 hooked up. I'm going to make sure that this is hooked up. And let me turn this off. Let me make sure that this is all good to go. Let me like reset the scope here. Cool. Are we on like normal mode or something? So my time base is about 1 millisecond. That's fine. My volts per division should be something like a volt per division. Not a millivolt. Volt per division, please. Interesting. Why did I flip my wires or something? Why is this so low? Why does this look like it's floating? So this thing is probably going more like... There we go. I was about to say, there's no way this thing is actually... is going that slow. So what you're seeing right now on the screen is this thing's... let me switch it to channel 1 so it locks in. So you are seeing the pin change from 0 to 1 to 0 to 1 to 0 to 1. And if I go quickly to the measuring pane, it's doing it 84,000 times a second. So that's pretty cool. Can you see that with your eye? No. But that's all this code is doing. So we have actually successfully controlled the LED. So just as a quick recap of everything that we did here, I'm going to terminate my debug session here. As a quick recap, we started from looking at the datasheet and figuring out what we needed to do to control our output. We could take a look through the schematic and try to understand it, but if you also look, there's also a table that just tells you if I want to set it as an I/O. Here's what ports you need to select to what to get that to happen. We assigned those ports, or assigned those registers, and we were able to take control of the LED through the output register.